So, welcome to the linked list implementation of a stack with Romare Newell. The first thing you'll notice is that we have a type-defined structure called node, and node has a character member called data, which stores the letters of the English alphabet, and node also has a pointer that points to the next element of the stack. After that, we have another type-defined structure called stack, which represents the stack itself. Now, stack has a pointer to the top of the stack, and it also stores the size of the stack. So we have some stack operations. Initialize stack is stack empty, push, pop, p, clear stack. Initialize is stack. Initialize stack returns true when successful and false otherwise. Is stack empty returns true when the stack is empty and false otherwise. Push pushes a character onto the stack and returns true if this push was successful and false otherwise. Pop pops a character from the stack. Pop does not have a return type. Peek returns a pointer to the top of the stack and returns null if the stack is empty. Clear stack returns all the memory that was allocated to the stack. So after doing that, we split the screen and include all our necessary header files. So the first header file we include is stat.h, then we'll include the standard input output header file, then we include the standard library file. So we now define our function initialize stack. Initialize stack will take the stack as a parameter. Sometimes I like to put my return statements first within a function. It helps me or prevents me from forgetting about it later. So we'll test if stack is equal to null. Sometimes programmers make errors and pass a null value where there shouldn't be a null value. So if we test if stack equal to null, we can avoid a null pointer error, and that's what we're basically doing right here. Everything after this is very straightforward. I think the whole initialize stack is very straightforward, but for beginners and persons who have never seen it before, it may be a little cumbersome. But here is it for you. There is no magic whatsoever. Very straightforward. Now, we're on to is stack empty. Is stack empty is a pretty straightforward function. Anytime the stack top is equal to null, then the stack is empty, and otherwise the stack is not empty if it's not null. So, we're on to the push function right now. So we just declared a temporary variable of type node, and we're allocating some memory to it right now. We're going to test if the memory was successfully allocated. Every time you allocate some memory, you should test if the memory was successfully allocated. If the pointer does not point to null, then the memory was successfully allocated, for all who didn't know. So everything after that is pretty straightforward, what we're doing on the screen right now. we'll do the pop operation. Pop operation is very easy and there's nothing complicated about it. We'll test if the stack is empty. So we store the original stack top. We point stack top to the next element within the stack and we free stack top right afterwards, which is the old stack top. And that's it, folks. There isn't anything complicated about a pop function, and I hope you can also do it as well. The peak is very straightforward. It's probably the easiest function you'll implement. Third stack is a very simple one. So we'll test if the stack is empty. And while the stack is not empty, we'll keep on popping elements until the stack becomes empty. And we exit the while loop and then we'll exit the function overall. And that's it.